Hello everyone, let's begin our daily question. So the first questions, we want to find out a 96% confidence interval for theta. And given that theta is equals to e to the mu minus 1, so we can get a natural estimator theta hat equals to e to the x bar minus 1, where x bar is the sample mean. Since the sample is obey the natural distribution, so we can standardize it, and then we can get a 69% of confidence interval for mu, which is x bar plus or minus 2.05737 times 2 over the root of n. And we have already know theta is equals to e to the mu minus 1. So we can put the interval of mu into this equation and get the confidence interval for theta. And the next question is like question A, but it has a little bit different. So given that theta is equals to lion sigma, so we use the sample standard deviation S to estimate theta. So we can get the x squared, and the estimator for theta is theta hat equals to lion S. Since we can use delta method to get the function g and the variance of the function g. We have already know the mean of the natural distribution is 10, so we can get the variance of lion S is 1 over 2n. So finally, we can get the 96% of confidence interval of theta is lion S plus or minus z of 0.02 times the root of 1/2 n. So we can get the interval. And next, question B is write down the likelihood function and find the MLE of theta hat with the information that there is 4 positive data and 6 non-positive data in our sample. So since theta is equals to P of yi equals to 1 and equals to P of xi greater than 0, and xi is obey the natural distribution mu1, so we can have theta is equals to the function 5. And we have already know the sample contains 4 positive data and 6 non-positive data. So the likelihood function for theta follows a binomial model. L of theta equals to theta to the power of 4 times 1 minus theta to the power of 6. And we can get the logarithm of both of sides. So the left-hand side is line of L of theta, and the right-hand side is 4 times line theta plus 6 times line 1 minus theta. And then we can take derivative of both sides, which is equals to 4 over theta minus 6 over 1 minus theta equals to 0. So finally, we can get theta hat is 0.4. And the next question, we should use the result in A and find estimate of mu. So from we can know theta is equals to phi of mu, and theta height is 0.4. So we can write theta of mu hat is 0.4, and we can check the standard table and finally we can get it. The mu hat is equals to approximately equals to minus 0.253. Thus, MLE for mu is this number. And question 3, the question A is find the mean and variance of x. So we use the formula. First, we can solve the mean is e of x equals to 1 times the p of x equals to 1 and 2 times the p equals to 2 over 2 minus theta. And then we can calculate e of x squared. It is equals to 2 plus 2 theta over 2 minus theta. So finally, we use the formula that the variance of x is equals to e of x squared minus e of x times e of x. So it is equal to 2 times theta times 1 minus theta over 2 minus theta squared. So we can get the mean of the and variance of x. And question B, we must prove the estimators theta and hat converge in probability to theta. So in this place, we use law of large numbers and defined g of x equals to 2 times 1 minus 1 over x. And then we will use the continuous mapping theorem. And finally, we can prove this one. And the question C is we want us to use theta and contrast approximately 95% of theta with the following data. So we have got the data and we can calculate the mean of the data. And after that, we can calculate the hat of theta n is approximately equals to 0.5714. And then we can get the variance of x and variance of x bar. Finally, we can use data method to get the 95% confidence interval. It is 0.5714 plus or minus 1.96 times 0.158. And 0.158 is the standard error, and 1.94 it is we have already know. So the interval is 0.261 to 0.881. And the final question is comment the interval gas found in C for theta. So there is a question that the interval is wide, reflecting high uncertainty due to the small sample size. And the point estimator theta in hat, the interval covers a fairly broad range, thus to get more calculate estimate of theta. So it needs a large sample size.